All right, let's go over a couple review problems for our upcoming quiz on Module 2. So the first section dealt with graphing or solving systems by graphing. So a lot of this graphing can, of course, be done on our graphing utilities and find the intersection. But for here, we'll kind of graph it by hand. So this one we have y equals negative 5/2 x plus 3. So remember, the second number in a linear equation is always the y-intercept. So I know I have a point here. And this is the slope. So this is your slope m, this is your y-intercept b. So the slope is negative 5, 2, so I'll go down 5 from my point, 1, 2, 3, 4, 5, and over to the right 2, and it gives me a point there. So my line would look something like this. Now for my other equation, x plus 2y, you remember from algebra, to get in slope-intercept form, we have to have y by itself. So I'll subtract x from the other side, negative x minus 2, and then I'll divide everything by 2. So I'll get y equal negative 1/2 x minus 1. Now the good news is if you're doing this on Desmos or a TI calculator, this is really kind of done for you. So I'll start at negative 1, my slope is down 1 over 2, and so it happens to line up just with that point. So I'm essentially trying to figure for my solution where do those two lines intersect, and it looks to me like that would be 2, negative 2. So the solution is simply 2, negative 2. If I wanted to make sure, I could plug that into my equations, and the first one I get negative 5 plus 3, which is negative 2. The second would be 2 minus 4, which is negative 2. So this is the solution. Now for our second one over here, again we have two equations. I do have to get the y by itself in both of them. So I have x plus y equals 3, so I'd have to move the x over, so y equals negative x plus 3. So this has a slope of negative 1 and a y-intercept of 3. And for the second one, I have x minus 2y equals 0. So I want to get y by itself, so I'll subtract x. So negative 2y equals negative x. And then I'll divide out by negative 2. So y equals 1/2 x. So the slope is 1/2, and there's no y-intercept, which means we'll just simply start at 0. So let's do this first line, y equals negative x plus 3. So I'll start at 3. The slope is negative 1, so it's simply down 1 over 1. And for the other line, we just have 1/2 x, but it starts at 0, so we'll go to 0 here, up 1 over 2. So it looks something like this. So I'm looking where this appears to intersect. It appears to intersect at the point 2, 1. So that would be my solution ordered pair to the system. And again, you can always check this, and I suggest you check it by plugging it in and seeing if it checks in both equations. Okay, section 2 dealt with some more algebraic ways to solve systems of equations. So the first method we talked about was substitution. So this problem I'm going to solve by substitution. The key thing was one of the equations you have to have one variable by itself, which in this case I have y by itself. And then I'm going to take that and I'm going to substitute it into the second equation. So I have y equals negative 5x minus 4. So everywhere I see y in the second equation, I'm going to substitute it with negative 5x minus 4. The key thing is you just have to have one equation that is by itself. So we have 10x plus 2 times negative 5x minus 4 equals 4. And we'll just go and we'll solve this. So I'll distribute the 2, so I get 10x. 2 times negative 5 is negative 10x. 2 times negative 4 is negative 8 equals 4. And this is one of our special situations where you'll see the x's cancel out. So we have no variables left. So all I have is negative 8 equal to 4. So when you have this case, we're either going to have our parallel lines or our coinciding lines where we have no solution or infinite number of solutions. But since negative 8 is never equal to negative or to positive 4, there's no number I can plug in to make that true. So this system would have no solution. So if you were to check this graphically, you would see that these lines never meet. They are parallel. So total. So let's look at this next one. We'll use elimination. Now the goal of elimination, remember, is we want to try to basically make one term the opposite. So in this case, I see I have the x's lined up and the y's lined up, and that's very important. You want to make sure that your x's are lined up on top of each other, y's, and then your numbers on the other side. Now you can eliminate anything. In my case, I think the easiest thing to eliminate might be the 3. So I have 3y on the top. So to eliminate that, I need a negative 3y on the bottom. So if I simply multiply the second equation by 3, I'll get x plus 3y equals 24. And if I multiply the bottom equation by 3, I get 6x minus 3y equals negative 3. And so the key thing is I do this, so when I add them together, those terms will cancel out. So these cancel out. 6x plus 1x is 7x. 24 plus negative 3 is 21. I'll divide both sides by 7, so x is 3. Now this is only part of the problem, because now that we have the x of 3, we have to, of course, find the y. So I'll just plug it into one of the equations. I just use the first one, so I have x plus 3y equal 24. So I will plug in 3 for x, so we have 3 plus 3y equal 24. I'll take away 3 from both sides. 3y equals 21. Divide by 3, y equals 7. So I have an x, I have a y, and the ordered pair solution would be 3, 7. Of course, I could plug that in, check, make sure it works, but it certainly should. All right, let's look at this third one. It says you can solve this by any method of your choice. So I can solve this by substitution or elimination. And if I look at this, I already see a y by itself. I see the y equals 1/2 x plus 2. So I would just go ahead and do substitution. So I would just plug the half x plus 2 in for the y. So my equation would be negative x minus 4 equals negative 2. And then instead of y, I'd have half x plus 2. Now the fraction looks somewhat daunting, but it is going to eliminate itself because I have this negative 2 out front. And negative 2 times half is just negative 1, or negative x. And then minus 4. This side is also minus x minus 4, so you'll see that when I start getting things on the same side, things are going to cancel out. I can add x, I can add 4, but basically everything cancels out, and I have 0 equals 0. So again, we said when all the variables disappear, there's two cases, either no solution or infinite solutions. Well, since 0 is always equal to 0, it did not really matter what I plugged in, so there are infinite solutions. There are infinite number of ordered pair solutions, and namely, they be all the ones that lie on either of those lines. So always watch out when your variables do disappear, because you could be in one of those special situations. If not, you'll get just a regular old ordered pair. Okay, finally, we'll look at section 2.3, which was some word problems, where we're trying to set up a system of equations and solve them based on some kind of situation. So this first one says an investor buys a total of 360 shares of 2 stocks. The price of one stock is $35 per share, the other is $45 per share, and they spend a total of $15,000. How many of each share did they buy? So the first thing I'm going to do is I'm going to define my variables. So I'll say x, number of shares of stock 1. Doesn't really distinguish what kind of stocks they are, so we'll just say stock 1. Y is the number of shares in stock 2. And our problem gives us a couple pieces of information. It says we bought a total of 360 shares, and they cost a total of $15,000. So those are going to be the two things that I try to build my equations on. So one, I know there's a total of 360. So x plus y should equal 360. The number of stocks in the first plus the number of stocks in the second should equal 360. As for the price, I know the price of each stock is 35 per share, and the other one is 45 per share. So that's 35 and 45, X and Y respectively. That gives the total amount you paid for the first one and the second one, and that should equal $15,000. So there is my system of equations. In class, sometimes we set up a table. That's also great. But in this case, they're pretty straightforward. So I'm going to try to do elimination, I think, just because it seems like the most obvious thing to do. I'll just eliminate X. So I'll just multiply by negative 35. That'll cancel out with the 1 on the bottom. So that'll be negative 35x minus 35y. And then don't forget to do the negative 35 times 360, which is negative 12,600. Second equation stays the same. Positive 35x, positive 45y equals 15,000. So when I add these together, those cancel. This gives me 10y. This will give me 2,400. And then I'll divide by 10, so y is 240. So I bought 240 stocks, 240 of stock 2. And now I'll have to find stock 1. The easiest way by far to do this is I know they have to add to 360. So if I just do 360 minus 240, I get 120. So there's 120 stocks, shares of stock 1. All right, let's look at our last problem. This is one that is a mixture problem. It says we are trying to mix candy that sells for $2 a pound with candy that costs $3 a pound to get 50 pounds of candy selling for $2.16 a pound. How many pounds of each kind do we want? So again, I'm going to start by defining my variables. So I'm going to say X is the number of pounds of candy 1. And Y is the number of pounds of candy 2. So I'll go ahead and make a little table. So I have candy 1, and then I have candy 2, and then of course I have the total. So the first thing I'll talk about is the amount. Well, do I know how much of each one I have? Well, I know there's X pounds of candy 1, Y pounds of candy 2, but I also know there's a total of 50 pounds. I also know there's a price per pound. So candy 1 is $2 a pound. Candy 2 is $3.60 a pound. The total needs to be $2.16 a pound. And then my final column is going to be total price. So if I have X pounds of candy, $2 a piece, $2 a pound, then that's 2X dollars. If I have $3.60 a pound for Y pounds, that's $3.60Y. And if I want 50 pounds at $2.16 a pound for my total, then that should cost me $108. And I got that simply by multiplying these two numbers. So my two equations are really going to come from here. The first one's going to be in this first column, and this second one is going to be from this column. So I'm going to have X plus Y equals 50, and I'm going to have 2X plus 360Y equals 108. And again, you can solve this by substitution elimination. I might just do elimination again, because multiply this by negative 2. So negative 2x minus 2y equals negative 100. 2x plus 360y equals 108. So when I add those together, these cancel. This gives me 1.6y, and this will give me 8. So I'll simply divide 8 by 1.6, and that should give me 5. So that's 5 pounds of candy 2, because that's what we defined Y to be. And to find candy 1, well, I know there is 50 pounds total, so I can simply just do 50 minus 5 and get 45. So 45 pounds of candy 1. And it makes sense because you should have a lot more of Candy 1 because the price is much closer to our total cost. All right, hopefully this is helpful for you. So take this and prepare yourself for your quiz.